In our last video, we talked on even and odd functions, and where we know evaluated that f of minus x is equal to f of x for even function, and for odd function f of minus x is equal to minus f of x. Now in this video we want to talk on Fourier cosine series, that means even functions. So we know that Bn is equal to 0, and the resulting f of x as derived in the last video is a over 2 plus summation n equals to 1 to infinity an cos nx, and thereafter a naught can be evaluated using this and an can be evaluated using this. So all we just have to do is evaluate a naught and an and then slot in into the formula. So we know that f from the question, we now have a question here. It says find the periodic series expansion of the periodic function of function f of x is equal to x squared. Now if we look at f of x, okay, is equals to x squared. Now if we evaluate f of minus x, we want to check if it is even or if it is odd. So wherever we see x, we put minus x squared, and this will give us x squared. So since f of x is equals to f of minus x, f of x is an even function. Now since it's an even function, we can now deduce that b9 is equal to 0. Okay, and our Fourier series f of x will be evaluated at a naught over 2, as we've seen before, n is equals to 1 to infinity an cos nx. So we evaluate a naught and we also evaluate an. Now we go back to our formula of a naught and an. You can see this is a naught. We can use this formula or we use this one. Both will give us the same answer. So a naught using this is 2 over pi integral from 0 to pi f of x dx. So a naught is 2 over pi integral of 0 to pi f of x dx. Okay, and we know that this is also the same thing as 1 over pi minus pi to pi of f of x dx. So we can, to confirm that they will give us the same answer, we can slot in our f of x and integrate. So let's use the first one, where f of x is equals to x squared from the question. So a naught will be equals to 2 over pi 0 to pi f of x is x squared dx, and this will give us 2 over pi. Where we integrate x squared, we have x cubed over 3 from 0 to pi. And now let's apply our upper limit and afterwards our lower limit. That will give us 2 over pi. Our upper limit of pi, that will give us pi cubed over 3, and lower limit of 0, 0 cubed over 3. This turns to 0, and we have 2 pi cubed over 3 pi, and eventually we have a naught to be 2 pi squared over 3. Now using the other formula, we have that our a naught is equal to 1 over pi integral of minus pi to pi f of x, which is x squared dx. Now this will give us 1 over pi. Integrating x squared, we have x cubed over 3 from limit of minus pi to pi. Now substituting our limit, we have 1 over pi. The upper limit is pi cubed over 3 minus the lower limit is minus pi cubed over 3. And this will give us 1 over pi cubed over 3 minus pi cube over 3 is minus pi cube over 3. So that will give us minus pi cube over 3. And eventually, this will turn to plus, because minus times minus will give us plus. And so we have it to be 1 over pi divided by 2 pi cube over 3. And that's 2 pi cube over 3 pi. So we can say that A naught is equals to 2 pi squared over 3. We have evaluated A naught using both formulas, and they are the same. Now, the next thing to do is to evaluate AN. AN is equal to what? From the formula, you can see that AN is equals to this. This is the formula for AN. That's 2 over pi integral of 0 to pi f of x cos nx dx. So we have it to be 2 over pi integral of 0 to pi f of x cos nx dx. And now our f of x is x squared. So AN is 2 over pi integral of 0 to pi x squared cos nx dx. Now the only way to integrate this format is by splitting it to u and v. And we know that uv is equals to u v1 minus u prime v2 plus u prime prime v3, the continuous. So our u is x squared and our v is cos nx. So u prime is 2x and u prime prime is 2. Moving on, u prime 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 is 0. So henceforth our v1 is equal to, that's integral of v dx, and integral of v, that's cos nx dx, they give us sine nx over n. And our v2, which is integral of v1 dx, that's integral of sine nx over n dx, which is going to give us minus cos nx over n squared. And v3, which is integral of v2 dx, is integral v2 is minus cos nx over n squared dx. And when we integrate this, we have minus sine nx over n cube. Now we can now go further and solve our an. To give us 2 over pi integral, starts with our u, x squared v1 sine nx over n minus u prime 2x v2 minus cos nx over n squared plus u double prime 2 and v3 minus sine nx over n cube from limit of 0 to pi. So with this done, we have that an is equals to 2 over pi. Simplifying further, we have x squared sine nx over n plus 2x cos nx over n squared minus 2 sine nx over n cube from 0 to pi. Now it's time for us to implement our limits. So an is equals to 2 over pi. Applying the upper limit of pi first, we have pi squared sine n pi over n, okay, plus 2 pi cos n pi over n squared minus 2 sine n pi over n cube. And moving on to the lower limit of 0, we have minus 0 squared sine n of 0 over n plus 2 of 0 multiplied by cos n of 0 over n squared minus 2 sine n of 0 over n cubed. Now the question now begins, what can cancel out and what will remain? Okay, so we recall that sine n pi is equal to 0. Okay, and sine n 0 is also equals to 0. So this contains sine n pi, so this term is 0. This contains sine n pi, so this term is 0. This is multiplied by 0, term is 0. This is also multiplied by 0, this term is 0. This contains sine n of 0, so this term is 0. And cos n pi, as we have here, cos n pi we have there, and it can either be plus 1 or minus 1, depending on the value of n. So in that case, when we simplify an further, removing the terms that are not defined to 0, we know that we are left with 2 pi cos n pi. 2 pi cos n pi over n squared. So in that case, we can now evaluate values of a1, values of a2, okay, values of a3, values of a4, values of a5, and also values of a6. So when n is equals to 1 in this equation, okay, we have that a1 is equals to minus 4 and a2 is equals to 4. We can call this a2 will be equals to 1. a3 is minus 4 over 3 squared. Okay, so a1 is equals to 2 over pi multiplied by 2 pi, because wherever we see n we add 1 over n squared as 1 squared. So this will give us 2 over pi multiplied by 2 pi, because 1 pi is 1, is minus 1 over 1, and this is going to give us minus 4. a2, which is 2 over pi, wherever we see n we put 2 over 2 squared. That will give us 2 over pi multiplied by 2 pi, because 2 pi is 1, which is equal over 4, and this will give us 1. a3 is 2 over pi, and wherever we see n we put 3. That's 2 pi cos, applying this formula, 2 pi cos 3 pi over 3 squared. That gives us 2 over pi divided by 2 pi, cos 3 pi is minus 1 divided by 9, and this will give us minus 4 over 9. Now let's stop at 8/4. That's give us 2 over pi, 2 pi cos 4 pi over 4 squared. That will give us 2 over pi multiplied by cos 4 pi is 1 divided by 16. And in essence, we have that this will give us 4 over 16, which is equals to 1 over 4. So, having evaluated a1, okay, to be minus 4, a2 to be 1, a3 to be minus 4 over 9, a4 to be 1 over 4. And also we evaluated that a0 is equal to 2 pi squared over 3. So a0 is 2 pi squared over 3. And since it is a Fourier cosine series, that is an even function, our f of x is a0 over 2 plus summation from n is equals to 1 to infinity of an cos nx. Now this can be a1, and we can write down to a4, and this will give us a0 over 2 plus a1 cos x plus a2 cos 2x plus a3 cos 3x plus a4 cos 4x. So we substitute our value for a0, we substitute our values for a1 down to a4. So a0 is 2 pi squared over 3 divided by 2 plus a1 minus 4 cos x plus a2 1 cos 2x plus a3 minus 4 over 9 cos 3x plus a4 1 over 4 cos 4x. Now simplifying further, we have that our f of x will be equals to pi squared over 3 minus 4 cos x plus cos 2x minus 4 over 9 cos 3x plus 1 over 4 cos 4x. Now with that, we have been able to generate an answer for the Fourier cosine series. Now in the next video, we will also talk on another question. We will solve another question as regarding Fourier cosine series.